Hi guys, so I'm back with our foundational OSPF labs. The total of 13 labs we're gonna do. This is lab number 1. This is I would say the biggest lab I'm touching, and then after that I will break it down into smaller pieces. So if you look at the topology which I have here, is that we have a point-to-point connection between router 1 and router 2. Remember, this is OSPF lab, so we are going to advertise the network, and OSPF deals these networks with the different network types, right? So for us, this is a serial interface network, which is point-to-point network, and then we have a Ethernet segment here, then we have another point-to-point, and then we have a DMVPN network here. So let's see. I already did the configuration of the routers to save time, so that my recording will not go above 15 to 20 minutes. So that's the idea. So let's open all the routers and see what configuration I already have on them. So if I open this and let me put it in a place where I can check it. Okay, so let's see. Sorry. So router 1, let's start with router 1, and first thing we will check is what interfaces we have. So actually what I will do this command on all the routers to see what I have, right? So that we don't have to type it on all of them one by one. So you can see I only have a loopback, and by the way, this loopback is /8 as mentioned here, and then I have the interface IP, and they are in upper state. Then we have router 2, we have Ethernet segment of 100, a serial, and the loopback, right? And if you look at the loopback of router 2 and router 3, they also have a secondary address, right? So if I show you the loopback, it has two addresses. It has a secondary address of 10 and the primary address of 2. Okay, so just to see how OSPF is going to act on the secondary interface. Right, so this is just to show you guys what the configuration is. So you can see that on the Ethernet we have 100, on Ethernet 0x1 we have a public network, because this is going to DMVPN router 8, and then we have a serial interface going towards router number 6. We have a loopback, and we also have a tunnel, DMVPN tunnel. So if I do DMVPN right now, you can see that I have two dynamic spokes connected, right? And if you look at my tunnel, you can see that I do not have any static entry. I just put the normal basic NHRP settings here. So I just started the process. I haven't done anything else, right? So with that in mind, the thing which you can do whenever you set up your lab is to verify the connectivity, okay? So you should always verify the connectivity. Let's go on and see what we have here. So you can see here we have defined that router 3 is going to be our NHS. So if you look at this, I have NHS, which is the server, which is the hub, you can say. So we have decided that router 3 is going to be our hub. So same configuration is going to be on router 5. Tunnel 1, you can see that router 3 is defined as the server, right? So nothing changed here. Very basic configuration on router 6 and very basic configuration on router 7. We didn't even have any loopbacks. Now let's move on. Let's verify that we have connectivity first of all, right? So and you can see that I'm not, before I do that, let's do that on each and every router, so that again we will make sure. If we do show IP protocols, we will see that I'm not running any protocol than NHRP on any of the routers. So router 1 doesn't even running that, and if you look at all the routers, I am not running any protocol whatsoever. The thing we will try to verify first that, okay, from router 1 I should be able to ping router 2, from router 2 I should be able to ping 3 and 7, and then from 3 I should be able to ping 4 public address, which is this, and 5 public address, which is 5.5, and also router number 6. So I can ping all of them. So if I can ping, I'm sure that the other parties can also ping me. So this is our basic testing, right? The basic testing has been done. What I have done between router 3, 4, and 5 is that I have a route defined. So if you look at, I have 2 static route defined on router 3, that how to reach 4. I can do default route as well. You can do that if you want. So if you go on router 4, if you do route static, because I'm not running any dynamic protocol with my ISP in our simulated environment, I have 2 static routes here as well. And then on router 5, I have 2 static routes here as well, right, which is going to router 4 and router 3. Now with all that in mind, let's move on and let's start enabling OSPF on these routers. So first thing first, what we will do is that we will configure OSPF area 0 on 2, 3, and 7. So in our switch or the Ethernet segment of 2, 3, and 7. Okay, and we will define a router ID, and that's it. Now from the OSPF perspective, if you are looking at it, you will see that the network type of this segment from OSPF perspective is going to be broadcast. Okay, and you should be aware that the timers on the broadcast are 10 milliseconds of hello and 40 actually 10 seconds of hello and 40 seconds of dead timer is in place when we have a broadcast network. The most important thing is that we have a DR and a BDR election on this segment because it's a broadcast. So DR BDR election is going to happen, and the router with the highest priority will be elected as the DR. Okay, so the default of the priority on these interface on Ethernet 0x0 of all these 3 routers, the default priority is 1. The priority range is from 0 to 255, where if you set it to 0, it means that the router is not going to participate in the DR BDR election, and it will not be a DR BDR ever. Now the next hop IP, where the router are going to transfer the routes, the next hop IP will not is going to be the originated router. So next hop IP is not going to be mine. So when I'm going to send you, router 3 will say, okay, the next hop is 7. I'm not going to give you my IP. Okay, the routers use multicast address of 224.0.0.5 and 224.0.0.6. So this is the basic stuff, right? Now what we will do is that we will continue in doing that, and we will make sure that we have our network running. So if we go on here, so we have 2 options. Either we can apply the network statement to everybody, or we do separately. So let's say router ID is 2. Usually what I do is this thing, right? So I'm gonna run it on 100 network, right? Because that's what we are planning to do on 100 network. So I'm gonna take this and I'm gonna use the best practice. So this one, and area 0. This is, we are just talking about area 0. Multi area is going to come in later, not now. Okay, so that's it. That's what we are supposed to run. So if you look at the configuration, this is the basic configuration we did. And by running this configuration, what we discussed is going to happen. That OSPF will say, okay, this I'm running on this Ethernet segment. This Ethernet segment type is broadcast. It has a DR BDR election. It has 10 and 40 seconds of hello and dead timer respectively, and it will have the priority of the interface is going to be 1, right? I'm going to do the same thing here. So router OSPF 1 router ID is 0003 and network is going to be this one. Okay, so that is it. So if you look at, you can see that I'm done. The neighbor relationship just came up. So include router OSPF, not include actually section router OSPF. So you can see that now I have the configuration. Same configuration is gonna go on router 7. Router ID is going to be 7. Network is going to be 7, and that is it, right? So here we can verify a few things, right? So first thing what we can verify, if I go to router 2, I can verify the neighbors. So the neighbor verification is show IP OSPF neighbors. If I check the neighbor, I know that 3 is the BDR and 7 is the DR other. It means that I am the DR, right? So I have been chosen as a DR. You can see that the priority for those are also set to 1. My priority is also 1. If you want to verify that information, you can look at show IP OSPF interface brief. This will give us the shortcut of that one. It tells that my process ID is 1, my area is 0, my cost is 10 for this segment. I am a DR and I have 2 neighbors. Now this 2 neighbors are full. And I think C is for connected, full, and they are connected. So I will check, verify that too. So if I look at the, instead of brief, if I say what is the status on Ethernet 0/0, I would say, I would have all the information here as well, that this is attached via network statement. I have a process ID of 1, I have a router ID of this is what we have set. I have a network type router. So this is the most important thing we need to keep an eye when we are running OSPF, that what the network type OSPF is calculating, because we can change it, right? So this can happen. We are DR, we have priority of 1. We are the designated router. We have a backup designated router. We have hello and dead timer. We have a wait timer. So what wait timer does is that it whenever you enable OSPF, it sends a signal that is there any DR, BDR there on the link. If there are none, for example, it will wait for 40 seconds to start the election process. Once the 40 seconds pass by, it will do an election, it will choose himself a DR in that case, right? And that's what happened. This guy chose himself a DR. Then router 3 came up. As soon as router 3 came up, because he knows that there is a guy on site. So you might have noticed that as soon as I entered the command here, it immediately gave me it immediately gave me that the loading is done, because it was already ran the process. Okay, it has adjacent with neighbor this, we are not suppressing hello messages, so on and so forth, right? So this is what we have on this one. The other command which you can use is show IP OSPF route. It tells you what route I have from the OSPF perspective, and then you can definitely always have database command where you have 2 link state right now. One is the router link state, and we are running 2, 3, and 7. These are the routers, advertising routers, and they are advertising how many links they have in their OSPF, right? And then because it's broadcast segment, we have a DR. So DR is router 2, and it's sending us the link ID. I am a DR on this link. So DR is on the link page, right? So if I run not in this section, let's say if I run router 3 to others, router 3 will say I am not DR on this side, but I can be DR on this side, right? So this can happen. So we have to be aware that not the router is the DR BDR, the link actually goes into DR and BDR state. So now let's do, I'm just gonna advertise, I'm gonna do it a bit quicker. It's already 15 minutes. So let's start doing that. Let's do it on router 1 and router 2. Right? Let's do that on router 1 and router 2. What we are going to do, we are also going to advertise Loopback on that. And we'll make sure that Loopback address is properly advertised. So let's start with that. So on router 2, I will say router OSPF OSPF1, and I will say network 12.1.2. This is also in area 0, right? And I will also run it on its loopback. So I will do network 2.2.2.0.0.0 area 0, right? So I'm doing it on second network, right? That make sure that router 2 has secondary address, right? So I only given the primary address, right? This is the primary address. Secondary is 10. Now I will go on router 1. So this is done. I will go on router 1 and I will say router OSPF 1. Router ID is 1 and the network is this one with area 0, and the network is this one with area 0, right? So if you look, very basic commands, right? Now if I look at the neighbor relationship, I should have one neighbor, and because that's a point-to-point network, on perspective with the OSPF, I do not have a DR/BDR election. There's no need of DR/BDR, so it just says full. And if I look at show IP OSPF interface brief, it will tell me that I have a loopback 0 where there's no neighbor, and I have a serial interface where I have one neighbor. And the cost of the serial is 64. We will talk about cost in one of our labs, so don't worry about it. And we have a state of point-to-point. So if I do this, you will see that we have network type point-to-point. This is the most important thing. As I said, there will be no DR/BDR. Adjacency will be shown here, that who is our neighbor. Now the most important command, show IP OSPF route, you can do that too, which is not literally run very much in an environment, in the production environment, because it doesn't tell you much. It just tell you that we have area backbone, we have intra-area route list. So intra-area means within the area we are getting 100 network, 12 network, 1 network. These are like connected to star, and then these are from the neighbor, I'm getting from the neighbor. So these are the best route we can say. And the gateway is 2, and there's nothing else. Now if I look at show IP route OSPF, this is where things get interested. So I am not receiving, number one. Let me make sure that what is the interface address. So yeah, I have 10.2.2.2, right? I have this, and I am not receiving this address here, right? I am not receiving it. I'm just receiving the primary address, right? So this is very important thing to note, that I'm not receiving the secondary address if we have this kind of situation. Now the other thing is that this network is not correctly advertised. This is not /32, it is /8. So, and this is going to be the same on router 2. So if I go on router 2, you can see that 1 is being advertised as 32. So to fix that, I have to go into the loopback 0 and I have to change the network type to point-to-point, right? And I have to do this here as well, OSPF network point-to-point. And now if I look at OSPF route, I can see that now my network received from router 2 is exact what the network should be from router 2, which is /8. So that's same gonna happen on router 2 as well. You can see that now I'm receiving /8 on router 2. So there's, and what I'm receiving, router 7 should also be receiving it, right? So if I look at show IP route OSPF, router 7 is receiving 1. Now remember, the cost of this link is 64, and router 7 cost of Ethernet is 10, right? If you look at this guy, show IP OSPF interface Ethernet 0/0, include cost. So you can see that the cost is 10, right? And the router 2 is sending us the cost of 65, right? Router 2 is sending us the cost of 65 because this is a loopback, not this link. So 1 for the loopback. If you look at the cost of loopback, so if I go on router 1, And if I look at show IP OSPF interface loopback 0 include cost, you see that's the cost of 1. So actual cost 64 plus 10, which is 74, plus the loopback cost of 1 cost be 65. So this is what 65. Oh, sorry, 75, which is what I'm getting here. So the most idea is, we'll discuss costs more later on, but the most idea is that I am receiving both the networks with the correct statements. Okay. So now I have covered router 1, 2, and 7 completely. Now we'll move on to router 3, because router 3 has, if you look at the interfaces and if you look at the thing I'm only using right now Ethernet 0x0. So we have serial, loopback, and tunnel. We are not going to do this on the public network, right? So we're going to do other networks. So let's just quickly continue with that, and I will have 36.1.1.3 area 0 network 3.3.3.3 area 0 and network 200.1.1.3 in area 0, right? So I have all three covered. What I can also do is that I can also say network of 10.3.3.3, which is the secondary address. I'm gonna do that too. Sorry. So I'm gonna do that too, right? So I'm advertising the secondary address as well. And on the loopback, I will say IP OSPF network point to point, just for the sake of. So I have done it on all of them, right? And so same I'm gonna do on router 6. On router 6 I'm gonna do the same. So if I go on to router 6, because it's connected, I can do show IP interface brief exclude assigned config T router OSPF 1. First of all, router ID, and then the network. Two network statements are going to go in there. You can have one network statement as well, like we discussed in EIGRP, that we have we can say 000255255, but I prefer this way. So later on we can change it easily. So now we have this. If you go on router 1, right? So router 1 is at the very end of that, and if that router is receiving route, so we know that everything is working fine. So if I do show IP route OSPF, you can see that I am receiving 2, I'm receiving 3, I'm receiving 6, but I'm not receiving 6 properly. I'm receiving 10, and I'm receiving 10 properly. It's actually 4. I'm receiving 36, I'm receiving 100. So let's move on to 6 and make sure that I'm advertising it correctly. Point IP OSPF network point to point. Here we go. So I think I did it on router 3 as well. Yeah, I did it on router 3. So router 1 should now have proper address of 6 as well. So you can see that router 6 is sending it properly. So yeah, that's the idea. So I think you guys are okay with that. And if you are okay with that, let's move on to other task, which is we are going to enable it on the DMVPN network as well, right? Now, by default, and this is, I'm not going to do anything. I'm just going to run. I'm already running on router 3. You can see 200.1.1 is there, right? So I'm already running on router 3. I'm going to run it on router 4 and 5, right? So let's do it on router 4 and 5. Config T, router OSPF 1, router ID 0.0.4 and network 4.4.4 0.0.0.0 area 0 and network, what network I have, 200.1.1.4.0.0.0 area 0, and in the loopback I will say IP OSPF network point to point. Okay, so this is router 4. I will go on router 5 and do the same quickly, so that you guys don't get bored. And I will put two network statement 5.5.5 0.0.0 area 0 and network 200 1.5 and area 0. So the problem what we are going to face here, right, is that we are not going to get, you can see that I have the neighbor, but I'm not going to get the neighbor. So if I go look at the neighbors, I have 6, which is point to point, so there's no issue with that, right? 2 and 7 are my Ethernet segment size, where 2 is the DR and 7 is the DR other. I'm the BDR, and I'm not going to get anything from router 4 and 5. The reason is router 4 and 5 and 3, if I look at the show IP OSPF interface tunnel 1, if I look at this guy is saying that this is a point-to-point network. So on point-to-point network, you will not have two hosts. And on top of that, because I'm running DMVPN, I am also not sending any broadcast on that network, because if you look at the configuration wise, interface tunnel 1, I'm not running any multicast. I'm not relying any multicast or anything, right? So this is another thing. So what I'm going to do on this case, right? I've already done on loopback point to point. On the tunnel interface of all these three, I will say that these are OSPF network type point to actually I will say non-broadcast one, right? So these are non-broadcast, and I'm going to do that on all of them. On 5, I'm going to do the same. Now, when you say non-broadcast, okay, then you have to define neighbors. Otherwise, neighbor will not be up. Okay, so you have to define neighbor. And to define a neighbor, two things are going to happen, right? So first of all, you have to define the neighbor, and on top of that, on router 4 and 5, we have to tell, because non-broadcast will also have DRB license. So on router 4 and 5, we have to tell that, you know what, you guys are not allowed to participate. So two things. So I will go here. I already did that. I will do IP OSPF priority to be 0, so that it won't participate. I will do the same on router 5. IP OSPF priority is 0, so that it won't participate. And then on router 3, I will say router OSPF 1 neighbor, and neighbor will be 200.1.1.4 and 5. We will see there are other options we can play with, and we will see how we can do that. So later on in the labs we will see that. So now you can see that we have attempt, and there will be DR others because they are not participating, right? So we have to wait a bit, and then we will see that router 4 and 5 are part of our network. Let's see how long it's gonna take. So it will take almost a minute, right? So it's, you can see right now it's half a minute almost. So let's see when it's gonna say that we have the so it's still not. Here we go. So now we have this, right? So once we have this, if I look at the show IP route OSPF, I should be seeing 4 and 5, and unfortunately I forgot something on 5. So let's go and put network point to point here, and let's check on router 1. So because router 1 is at the other end, we should receive. So we have to wait. Now it's fine. So we have 2, 3, 4, 5, 6, and 10 network from 3, and then so if you what we have done, right? What I want to do on router 2 is to advertise a network, right? The loopback, but I do not want to advertise the secondary address. So what let's see what I'm talking about here. If I do this here, show run section router OSPF, if you look at, I am not advertising 10 here, which is fine, right? Which is fine. If I am not doing this, let's say if I say this router OSPF 1, and if I remove this command from here, right, and then I go into the loopback, and I could say IP OSPF 1 area 0, right? If I have done this command under the interface, and if I have gone to router 1 and I look at the OSPF, now you can see, just wait. Now you can see that I not only I have two network, but I also have the 10-to-2 network, right? So I'm getting both of that. Now what if I do not want to advertise this? Then I have to go on router 2. I have to go, and I cannot do this on the router statement because router statement is pretty clear. Whatever IP you're gonna put, and that's what we saw on router 3. So if I go in there and I say IP OSPF 1 area 0, and then we have secondaries, none. So I don't want to advertise secondaries. If I do this, go back to router 1, give it a time, and you will see that route goes away. So secondary is not being advertised. So this is one thing you guys need to know. So that is it, guys. That is our lab number 1. It's a big lab, right? I even though I skipped the initial configuration, but it's still this is the big lab. So I would like you guys to do this lab, practice on it, and then see how it goes. We are going to cover each and every little detail of OSPF in these foundations. Okay, thank you. Have a good day. Bye.